Hello, this is John Cleland again. I'm recording my third video regarding my transmission system model database. If you've watched the first two, you've seen this outline of the various aspects of the database before. And of course this is the condition it was in at the very start in my first video, where I had only done buses, lines, and within lines the impedance and rating. And if you'll recall, my reservation at the end of that video was I didn't really know what I was going to do with plotting diagrams. So during the 2 or 3 months after I finished this stuff, I moved on and had an epiphany, I guess you'd say, and I figured out how to draw diagrams. So that was what my second video was about, actual diagrams drawn inside the transmission system model database. At this point, I've done several more months worth of work, and let me show you the state of this page at this point in time. At this point, I have done zero sequence mutuals. I've done generators, including generator impedance, reactive voltage control, and dynamic stability models, both the models, the governors, the exciters, the stabilizers, etc. And I'll show you all of these things as we get into it. And I've also done some additional changes, an additional feature in the diagram drafting. I've done 2 or 3 other things in the program overall that I want to show you in this, my third video. Before I get too far into it, let me give you some information, my contact information to start with. My email, I have 2 emails, jocleland4@gmail.com and john.cleland@epb5.com. Let me mention to you that if you want to, I can provide a prototype of the entire program in its present condition. It runs in a standalone mode on Windows via the executable, the support files, and SQL Server DLLs. It's actually running on SQL Server Compact Edition. That's why I can send you something that will actually run without even being installed on your machine. But I don't want to send it to just anybody. I want to filter how serious you are about it, what sort of organization you work for. I really want to emphasize serious utilities. If you're interested in procuring my software, and if you're interested in performing something similar to that, please note that I'm not trying to give you a finished product. I'm well past the age of you depending on me to write your software for you. What I want to do, if you're interested, is I'm offering my software source code, not the complete finished executable. And then you could take it and add features, modify things, fix bugs, etc. And in that way, you can own your own program. If you want to, I can perform additional programming for you if you need it, but ultimately, for the long term, your company should be able to update and modify its own version of the program. You need to own your own copy of the source code. But I do want you to recognize the knowledge, expertise, and experience behind my software. I was involved in the original plot program in the original database at TVA back in 1980. In the early 90s, I volunteered to convert the program over to FoxPro. And over the next 20 years or so, I was the person who was almost alone in charge of the software itself, of all enhancements, bug fixes, just the progression of the software over the years. They're in the process of rewriting that software today, but at the present time, they are still using the FoxPro version that I wrote. And let me also take this opportunity to mention that I do have an overhead transmission line constants program. It's a GUI program, and it is a complete program. If you want a demo, I can give you a demo program of that you can run just like the TSMdB program. It will run on its own. In fact, because it's not a database, it just runs simply using the executable and the support files that come with it. Now, I said in TSMdB that I really think that what you want is my software source code. The OHTLC program is complete, but I might and emphasize the might, entertain offers for you to get the source code as well. So that's just some starting information, and now let's dive into the changes and updates and things that I've done to the program since my second video. The first thing I want to show you is an enhancement I've made to the diagram drawing. There's a button over here called Select. If I hit that button, it pops up a little box that I can make larger, smaller, whatever, and I can move. So I'm going to move it right here, make it a little bigger to cover the next button there. Then I have some buttons over here. This is inclusive and exclusive. If I hit the inclusive button, that says that every element that this box covers, even a part of, is going to be a part of the move. So if I hit inclusive, then I move the box. Everything that was inside that box, even partially, it can be moved. Then I hit done, the buttons reappear, and it's moved. Let me illustrate the exclusive feature. If I hit the button, maybe make the box a little bit bigger, go over here and put it in the same place I had it before, and you'll see these two lines are not inside the box completely. So if I hit exclusive and then move, I only move what was fully inside the box. And I hit done, and you've effectively moved whatever you want to move. Of course, you can move anything individually that you want to. So that's one drawing feature that I've added. Another thing I've added is printing the screen. Here's a print preview button. If I hit the print preview button, I get a preview of the screen, and you'll notice that I make all the buttons go away so that you've got a clean picture of what's on the form at the time. There's also copy to the clipboard. So if I hit that button, the form that's on the screen has been copied to the clipboard and can be pasted into any document. Now you'll notice there's an extra button up here. There's the standard form closing button. Here's an extra button that I've built. I call it Super Close. What it does, for example, let's go to a line, open the line, open the rating form of the line, and let's even go one step farther and open the edit algorithm constants. You can see in order to get back to the start of the program or to get out of the program without that button, I've got to go out, 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 and I'm finally out with one more press. Now let me get back to that point. And at this point, I'm way down into the program. I want to stop and get out of here. It's time to go home. I want to quit. Hit that button and I'm totally out. There's my program that's recording my sound. And let me stop just for a minute and show you that all I'm running here, I've got an executable, I've got 3 data tables, and I've got a conductor's data and a settings file. Both of these are comma delimited, and of course in order to run it free on your machine, I would have to give you the DLLs to run SQL Server Compact Edition. Now let me show you one other enhancement I've made. This with regard to transmission line impedance checking. Let me open a transmission line, open its impedance record, and you can see this new area right here, impedance checking, which is optional. But what it does is using phase spacing and conductor size, miles, number of phases and bundling, etc. It performs a positive sequence RX and charging, as well as a zero sequence impedance check against the numbers that you've entered. You can see that the check here shows pretty close correlation. If I change this number, let's say to 5, you can see that this number here, the X1 component, is now out of tolerance, and I've got a warning. If I try to save it now, it's going to tell me that at least one line impedance check is outside warning levels. Do you want to save the data in this condition anyway? I'll say no. If I change that to 7, you'll see that this is now red. It's still calculating the original value, but that is way out of tolerance with the 7 that's been entered. And if you try to save it now, it's going to give you a warning that says, I'm not going to allow you to save it in an out of tolerance mode. Now, there's also the grounding over here. Positive sequence impedance can be estimated fairly well, very closely, using the little shortcut factors for phase spacing. Zero sequence impedance is a little more problematical, and you really only get in the ballpark. Now, these numbers look good here, but one thing I've added is grounding. Grounding is a significant contributor to zero sequence impedance. So let's watch this 10.81 as I change the grounding. If I go to poor grounding, it rises to 13.48. And poor grounding would be high earth resistance and very few ground wires. If I go to good grounding, it drops below down to 8.14. And of course, good grounding would be low row or low earth resistance and maybe multiple ground wires or several very good ground wire conductors, such as optical ground wires. But all this is a means of giving you a check after you've entered the conductor information for up to 3 different conductor sections in the line. It'll calculate an impedance check and give you an idea of whether you're in the ballpark. Of course, what you're trying to do in the positive sequence, you're trying to get pretty doggone close in your estimate. In the zero sequence, you're trying to get in the ballpark. And it's helpful when you're putting in data to make sure that you haven't put in some bad numbers. Anyway, that is line impedance checking. Well, by now you probably have noticed that this diagram doesn't look exactly like the same diagram in the previous video. And you're right. What I've done is, over the last several months, I've sort of started over again. In one respect, I've added bays, which are essentially zero impedance branches, in order to make this more of a node breaker model. However, the line data still contains all the information that you need in order to do a full breaker-to-breaker line in a bus branch model. But what it doesn't have is the spare information that the previous version had. Now, of course, I could go back to that old version and redo the lines to where it has the spare. But at this point, it has bay information. That's a bay. And here's the rating data for it. It's got a bus rating, switch rating at one side of the bay, and etc. On the other side of the bay, relay settings, etc. It also has room for the 9 switch in a transfer bus configuration. So this is a bus breaker, node breaker model, more or less. And I can show you very starkly how that looks if I go to the big drawing here of the 500 station, and you can see I've drawn a transfer bus with a spare bay and all the transfer bays in it. The spare bay obviously is a bay, a breaker bay set up as a spare. And let me show you another version of this same drawing just to show you how this drawing could be drawn if, for example, the spare breaker has different ratings for different applications. Let's suppose it has one rating for sparing out 914, but a different rating for sparing out 924, etc. on down the line. So I've drawn a slightly different version of that drawing. And you can see here that I simply connect 904 to the main bus 4 times. So that version of 904 would have all the information in it that pertains to its sparing of 914, that version of 904. Now these would be totally separate records in the database. That would be one bay record, this would be a bay record, etc. But that's a way that you could do a main and transfer where the spare breaker, it has different ratings for different applications. Let me go back to the main one. Of course, there's still all the next buttons. I want to get back to the drawing I had. Here's the same drawing at a future date, which has a tap on it. And again, in keeping with the node breaker model, I've added one other feature to buses. Let me show you. This is bus consolidation. Now, this was my feeble attempt to provide a way to consolidate from a node breaker model down to a bus branch model, and I've actually given you the ability to do two different levels. I don't know whether this would really be useful or not, but that's one thing I've added in there. And let me show you how it works. One thing that I added to the diagram, I can show you all the buses that are consolidate level 1. There's 1, 2, 3, 4, 5, 6. And then I can go back and have them not show and consolidate level 2. None of them are consolidate level 2, and then consolidate level 1 and 2. So you can see what buses are set up as consolidating buses. Now let's move on to another category, generators. You see there's a generator button right there. Let me go back to that big drawing I did a while ago. You can see that I've got generators. So I've added generators to my database. And let me open a generator. Well, before I do, let me show you how they work in diagrams. The generator stub is the only thing you can move around. So I can grab that stub and move it, and when I let go of the mouse button, everything moves with it. Of course, I can position the notation to the generator. I can also open and change various facets of that. Also, if you only move one end, just like a line, the generator is going to be reoriented so that it taps onto the end of the stub directly in line with the center of the generator. So if I move it again, if I move this end, the generator moves when I let the button up. So let's go look at this generator in data. Now, very much like lines, in lines we have a line defined, and then you can, in a subtable, you can define various rating periods or various impedance periods for that line. For example, if a line is reconductored, you could have it with one rating from time A to time B, and then another rating from time B to time C. The same thing is true of generators. So here is a generator on bus 532.811, machine ID 1, and it's got an overall in-service date of 1/1/2010 to 12/31/2099. Now, I've only given it one data period, the entire period, but like lines, I can break this down into sub-periods. For example, if you have a change, maybe you rewind the generator and it's still the same generator as far as bus and machine ID, etc. You still have the same generator, but it may have a different impedance, or you may have changed one of the, maybe a stabilizer. You changed the stabilizer and it needs a different definition for a different time period. Now let me go to the generator data. Of course, there's in and out of service date, base generator, base MVA, base KV. There are various impedances. The grounding is I let you say what type of grounding it is, whether it's equivalent ohms transformer or just actual ohms. Give you the ability to define a D curve for the generator, and also I'll let you graph the D curve. Now this one's a little odd. I think I may have not given those minus numbers. Now let's graph it again. You can see the D curve, and it'll fill in wherever there's missing data. I've programmed it to fill in. Voltage regulation and the bus that the generator is regulating. Winter peak, spring peak, summer, fall, etc. Off peak. Station service. You can define station service here, and then finally, I've got it where you can add model data. Now, for example, this one I've defined a gen row, and if I open the edit of the gen row for this generator, you can see that I've sort of given you a good look that mirrors the data that you see in PSSE or some other definition of a standard GenRAL model, and then here's the data that you would put in for that model. Now, what I've done, and let me go back a little ways. Let me go back to the front. So here's the GenRAL model for that particular generator, and I've actually said that this GenRAL model would work for both Unit 1 and Unit 2. I've given some information and the data. So if you go back in the data and look at Unit 2 on its bus, you will see that it also references this same GenRAL model with these same GenRAL values. I'll do that real quick just to show you that. I'll go to the so here's generator number 2, and I can access it by hitting the text based with the generator. Go here, and you can see the GenRAL model is the exact same model as attached to this generator. And here's the governor model attached to this generator and number 2. I pretending that you use the same governor model for the second generator. So that's generator data and how to draw generator data that I've added for this version in this video. Now before I move on to one more item, let me cover things. I'm doing the video in segments, so let me refer a little bit back to the previous segment talking about the generator. If I go back to the generator data, I didn't mention the unit availability. You can assign any generator either as base load or dispatched, and I misspelled dispatched, didn't I? And that also refers to economic order. And if you have a forecast of all your generation, minimum generation for dispatched generators, and connect it up via the forecast ID, you can put your generators in order, and in the create program that creates the raw data file, it would go down the list and it would turn down dispatched units, keep baseload units, etc., until it had obtained the generation level that you want. And of course, with regard to min and max Q, let's suppose the generator output was in this vicinity. Well, it would come up with a min and max Q by extrapolating or interpolating across the D curve. So that's just a little bit more about generation that I forgot to mention. But now let's move to another subject that is not a subject that is referenced from the diagram, and that is mutual data. Let me open a mutual data record. This is the mutual data where you pick two lines to say that they are mutually coupled. You give it the coupled length, the zero sequence coupling impedance, and you can give it B factors. Now, the way this works right now, without this checkbox clicked, it's going to actually calculate the B factors based on the line lengths and the coupled lengths. So if I change this B factor, say to 0.1, it's going to recalculate and redraw. So this B factor now begins 10% down this line and ends 0.8688. Of course, this line is 10.64 miles long, and the coupled length is 10.64 miles long. Now, if I change this, say, to 5 miles, it'll recalculate everything. This one now starts at 0.1, ends at 0.4613. This one starts at 0 and ends at 0.4699. If I change this to 0.3, it's going to recalculate and redraw. And you can see that I have the mutual line reversed. That's because This is the direction, and this is the beauty of this form. You can see graphically how the two lines relate to one another. This line, Baltimore toward Washington, Annapolis toward Washington, that's the way these relate. And you can see that that's not the order of the buses in the lines themselves. But if I unclick that, it's going to reverse them. And now you can see it's wrong. Washington's at this end here, Washington's at that end there. Now this is, as I said earlier, is a node breaker model, which means that you seldom will have the exact same bus on each end. This is the end of the line, not the bus at the end. But if you do have a bus, then it's the same bus. These two will be tied together with a little piece of drawing, and you'll be able to see that the two buses at that end are the exact same bus, and you can still do all the impedance and B factors. Now, if I suspend B factor calculation, that says don't use the miles, don't calculate B factors for me. So I can actually change this to 0.7, and it will actually give me 0.7. Did this change? I don't think so. Let me go to 0.8. Yeah, see, nothing is being recalculated. It's just simply giving you the B factors you asked for. It's drawing the drawing the way it needs to be drawn, but it's a good visual picture of how the mutual data is. So that's my mutual data. Well, I'm about through with this video. This is a little bit amateurish, I'm sure, and you probably thought I was a little crazy at times, but I hope I gave you a good idea of what was in the program. And here I am with my email addresses, and I want to reemphasize one point, and that is I'm not in the business of providing finished product in the realm of the transmission system model database, because in the long term I can't support you, but I am in the business of providing software source code that you can then modify, add to, etc., and own over time. So that's one of the biggest points I want to make when you consider this, so that you don't dismiss me out of hand simply because I can't provide you long-term services. Another thing I want to mention is some of you may already have your database program in operation, and you're really not interested in this. However, maybe you noticed that the diagram drawing was something that was very interesting and would be very helpful to you. I can show you how to do that. I can provide the source code that does that, and maybe you could add that to your program, and the diagrams are a significant improvement in the way this program operates. So just give me a call, give me an email. I really wish someone out there would see this and say, this is very interesting and could be very helpful to your organization, and shoot me an email and let me know. Thanks a lot.